that's the way you go. You experiment and play around. And try to find things that are useful for your own work. Yeah.
Okay, just to answer the question with the user interfaces, you just open a search and just say SQLite user interface. And since we are working on Ubuntu and not on Windows or something like that, we just type Ubuntu SQLite user interface. Google opens, and let's see what the first hits are showing us. So there's a GUI editor called for SQLite databases. It's called SQLite Browser. Again, SQLite Browser. The next step is saying SQLite Man has a bit more stars than the SQLite Browser. And then again we have SQLite Browser. So let's apt get install. Okay. apt get install, and let's try SQLite Man, for example, because it's got more stars. Yes, we want to install it. Okay, since it's installed, and since it is a graphical user interface, we should check under Applications, Programming, if there's a new entry. Yes, there's SQLite Man. I can open it. Nothing in there. I have to open a file. Open. Okay, then it's already there. Select, and there's my SQL database. Tables, person, site, survey, visited. And I can see the entries here. I even have the item view. Okay, for each item, I go through it. And I can do lots of other stuff. And this, I think, is, it could be, I don't know, true as well. It's just clicking, testing, trying. We can do let's do it that way. So I think that this is something where you can type SQL statements, because there's something like run and all that stuff. Yes, run SQL. So we just do SQL star what was it? Visited, for example, visited. Let me just say run. No such table visited. Okay.
Visited was just a row.
Visited. So if you're not happy with that one, you can do.
Do you mean it's the same as the other one, as the SQLite? It's just it's somehow more user friendly, or
it's just the user interface.
Or
just
more.
The one was the
same command but displays it differently. Okay. Yeah.
And if you don't like it, you can try SQL Browser. It was the other suggestion.
Probably the user interface is better, or easier to enter values or change some values in the table.
Let's check. And there's also now installed the SQL database browser. It looks a bit different here. Oh, open, SQL lessons, ServerDB, open. And same here. You have your tables here. You can browse the data. Okay? And you can execute some SQL. So ask Google for help when we are not here.
Is that some limitation for the size of the table?
No.
Would it be possible to quickly show us how to take an Excel file and turn it into a database file?
And connect different database Excel files to have
You don't want to work with Excel files.
No, but
But
if
yeah,
we just now.
If you have Excel files right now, it would work that way that you use the Excel file with Excel. You use an export as or something like that to create a CSV file, for example.
yeah, that's what I'm trying to.
And then you use the command line, or you use a Python script to read the CSV file and to put it into a database. And this is something that we were missing here to do because it is just scratching the surface, selecting the data out from the database. But what is missing is creating a database, setting the schema of a database, inserting data, maybe not just with SQL, also writing a small Python script. But doing this could fill also 3 days just working with databases. So it's a huge thing. If you would like to do, I think there are lots of books out there. You can buy one at Amazon to make sure if you are not just focusing on SQLite, for example. You should find a book that is using or is covering SQLite and Python, for example, so that you not only have lots of SQL statements and you don't have any connection how to integrate it in your Python script. So you should find a book where it's shown which SQL statements can be used with SQLite and how to embed these statements in your Python script so that you can write Python and start creating first a database and then use Python by reading a CSV file or something like that and storing it in the database.
I was hoping to find a way of importing this CSV file directly. I'm not sure if it works, but I'll try it.
So it was just I don't know how to say, I mean we covered a lot in this 3 days, which is just scratching the surface. You just get introduced into something. There's much more. And then you have seen that you can do several things with the command line. You can do things by using Python. You can do things by using SQL. And it's up to you to find the way that is best working for you, and maybe also go to other workshops or something like that where in detail it is explained how SQL is used to create a database, to fill the database, to read the database in Python or with Python, to make analysis with data in the database. So this really is filling a lot of days again to get known how to use it. So if there are no other questions, I think
Well, I'm sorry, there's one topic that is, I feel, that we have not covered that I feel is really important. So if you want to advance as a programmer, you should look at look at the combination of 2 things. So one we talked about, the version control. And then there's a sort of philosophy of programming called TDD, so test-driven development. So what that means that whenever you write a new function, you start by writing a test. So another function, a test function, that calls the function you intend to write and verifies that you get the output you expect given some input. So the principle is you start by writing a test, which is a way of documenting for yourself how your program should work. And then you write the code itself, and then you go in circles, and then rerun the test and see if it works. And it fails, you continue editing, and when the test finally passes, then you stop coding and larger than the production flow. And that the testing can take a little more time initially, so you may be tempted to skip that step, but the time, in the long run, the time savings are huge if you go into this thoroughly. Python also has a lot of different tools for testing different levels. Because we didn't cover this here, that's my advice. Next level of your programming skills is to look at these principles and get used to this workflow.
So this especially makes sense when it's up to critical systems, which are developed by lots of people and which have millions of lines of code. Because one would change something and thinks, hey, for my use case now I did an extension and what worked before still works, and what I've added works as well, and then there are hundreds or thousands of these tests, and he also had added his test, and then he's running all these test functions, and then suddenly 3 or 5 show that there's an error, which basically means that the extension this programmer was doing is raising errors somewhere else in this big critical system. This is why this is needed. So it's a way of how to develop critical systems with a lot of code and where several developers are working with it. And you will not, when you learn programming, you will not start with these test-driven development, but you should, as Olaf said, you should read something about it to get the principles, because it means when you have written a good piece of software that you really want to publish to the outside world as a release or something like that, providing source code as free and open source software, and you want to encourage others using this software, extending this software, building releases on their own, you have to support them somehow by doing this. You are doing this by documentation, and you are also doing this by providing test cases. So that they can make extensions to it, run the test cases, and finally know that their extensions didn't harm what you have programmed before, and that everything that you have programmed before is still working the way that you have intended it to work. But this is something where you also have to consider that it will take resources. So it means when you are writing your program, then you are writing the test cases in parallel to that, and it means you need the resources for that. So it's really, you have to really consider if you have the resources to do that. So it's good for sustainability, it's good to make sure that the code is working even if someone else is changing things, but it means you have to spend more time to implement these test cases. And quite often researchers do not have the time or get funding for writing test cases. And this is why writing research, writing software and research is a bit critical, because we only just write some lines of code, and if it works in the end, everything is fine, but no one else can use it because there's no documentation, we don't get any resources or money for writing documentation, we don't get any money for building releases and publish the software, and we also don't get any money for writing test cases. So it's a bit something that will change, and that has to change with you. You are the next generation of researchers.
It takes just a little more time in the beginning, but in the long run you save a lot of time.
Yeah. Okay, then I would like to thank Marika and Olaf. They did a great job. Speaker today, it's Christoph. He's coming from, or he's involved in this Foster project, and he has 2 lessons for open science, open data, open access, and he will introduce that stuff to you. I think it will fit very well because we have covered databases this morning, and he will talk about open data. And in the end, I will finish with a small lesson about software so that we get a bridge from data to software again. lessons, I think you have also some practical tasks for the students. That's what I've understood. So the next two lessons are with Christoph. And at GFZ, our public relations section has prepared something for you. So let's have a look what's inside. So there's a mouse pad, really important. There are 2 pens, something like this, and a small brochure. So if you like to take one, I think the public relations would be okay, then we will start in 10 to 15 minutes.